All right, so in this video, I'll be talking through page 3 in the Unit 3 notes packet. Here we're talking about direct variation, and this is when two variables move with each other. So this is kind of the simplest case of a line. That's kind of why we're starting here. So for example, if we look at example 1, Damien has a business making small cars out of wood. For every car that Damien makes, he needs 4 wooden wheels. Complete the table below and graph the relationship. So X is the number of cars that he makes, Y is the number of wheels. So if he makes 0 cars, he needs 0 wheels. If he makes 1 car, well, each car has 4 wheels, so he needs 1 car, or 4 wheels. If he makes 2 cars, then he needs 8 wheels, because each of the 2 cars needs 4 wheels. And then 3 would be 12. Hopefully that's pretty straightforward, that 3 cars, each with 4 wheels, 12 wheels total. Then we can graph those points like this, and we see that we get a line, right? 0, 0 is here. This is 1 comma 4. This is 2 comma 8. And so we have a constant of proportionality. That's the rate that they change at, right? For every 1 car, we need 4 wheels. In this case, it's also a slope. So not all slopes will be a constant of proportionality, but all constants of proportionality are slopes. So that just tells us every time that x increases by 1, what is the corresponding change in y? And so if we look at example 2, for each of the equations below, complete the table and graph the points. So as x increases, so first of all, actually, we have this equation y equals 3x. This means whatever x is, we plug it in here, we multiply it by 3, and that gives us y. So -2, well, -2 times 3 is -6. -1 times 3 is -3. 0 times 3 is 0. 1 times 3 is 3. 2 times 3 is 6. And so we can see that our slope here is going to be 3, because every time x increases by 1, right, we're adding 1 there, adding 1 there, adding 1 there. On the other side with y, we're adding 3. And there is no need to assume that a slope is going to be a integer, right? We can deal with fractional slopes. That is totally okay. So for example, if we have y equals -3 halves x, well, let's start with the positive ones. So when x is 0, y is 0. When x is 1, well, y is going to be -3 over 2. And when x is 2, y is going to be -6 over 2, right? Doing 2 over 1 times 3 over 2. And we know that that's -3. And we notice up here that up here we're multiplying, we're essentially doing the same thing, except you have one more negative. So now -1 times -2/3, that's going to become +2/3, right? Because a negative times a negative is a positive, so it's going to look like that. If we go ahead and graph it, we have -2, -3, -1 and 3 halves, and 3 halves is halfway between 1 and 2. 0, 0, 1, -3 halves, 1, -3, like that. The lines can go down that way. One way we can think about this is for every 2 units we cross in the x, we're going to change 3 units in the y. So I'm kind of foreshadowing the next page a little bit here, but we can think about that as a slope of -2/3 means for every 2 units you go right, you got to go 3 units down. So the slope here, that's -3 over 2. And example 3, now we just have some points. We're trying to go the other way. What is um, the constant of proportionality here? Well, we see that when we go from 0 to 1, when we go from 0 to 1, y goes from 0 to 8. When we go from 1 to 2, y goes from 8 to 16. So each time we're increasing by 8, so our slope is 8, meaning that the equation has to be y equals 8x. And just to clarify that, the positive slope means the graph goes up when we go right to left. Negative slope means it goes down. So this is a case of a negative slope here, because as we move from left to right, the graph is going downwards.